Alright, in this video we are going to be working through some examples. Before that, let's quickly recall what we talked about last time. Here I have the graph of some function f, and I've marked a particular point on the graph. X-coordinate is a. We defined the slope of the graph of f at the point a, comma, f of a. We denoted it with this notation f prime of a. And we also noted that this is actually the derivative of f at a. Now, having to say that it's the slope of graph of f at the point a, f of a, that is a mouthful. So more simply, I'm just going to say the slope of f at a. Now, we had these formulas for f prime of a. So it's the limit as x approaches a of f of x minus f of a over x minus a. And then equivalently, you can also compute it using this formula instead. The limit as h approaches 0 of f of a plus h minus f of a over h. Now, in the last video, we started by looking at the parabola, y equals x squared. And we were looking at the point 1, 1 on the parabola. And based off what we did, it seemed like the slope should be about equal to 2. Now let's try to prove that that is actually the case. All right, so I want to compute what's the slope of this parabola when x is equal to 1. So using the formula, let's do the limit as x approaches 1 of f of x minus f of 1 over x minus 1. All right, so recall f prime of a was the limit as x approaches a of f of x minus f of a over x minus a. And all I've done is I've plugged in 1 for all the a's. All right, so we have a limit that we're trying to compute. In this example, f of x is the function x squared. When x is 1, f of 1 would equal 1 squared, which is just 1. Then we're dividing by x minus 1. If you plug in 1, you're going to get 0 over 0. Because this is a polynomial over a polynomial, my strategy is to try and factor it. So I'm going to factor my numerator as x minus 1 times x plus 1. From here, we can cancel out the x minus 1's, leaving us with the limit as x approaches 1 of x plus 1. And finally, if we plug in 1 for x, we're going to get a final answer of 2. So indeed, f prime of 1 is equal to 2, meaning that the slope of the parabola at this point is equal to 2. All right, let's try to do some other examples. All right, this time let's consider the function f of x equals 1 over x. All right, so its graph will look something like this, roughly speaking. And here I'm going to mark the point 2, 1 over 2, or 1/2. And let's try to find what is the slope of the graph of f at this point. All right, so we're trying to compute the derivative of f when x is equal to 2. Now this time, let me use the alternative equivalent formula for the derivative. So I'm going to use the one that had the limit as h approaches 0. Now it doesn't matter which of the formulas that you use when you're trying to compute the derivative. Both formulas are going to give you the same answer as long as you do your work correctly. And in my experience, neither formula is easier than the other. So there's not really any benefit to using one over the other. It's just your own personal preference, I would say. Here to illustrate it, I'm going to use the limit as h approaches 0 formulation though. All right, so it was the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so let's see what that looks like. So f of x is 1 over x. So f of 2 plus h is 1 over 2 plus h. Next we have minus f of 2, which would be 1 over 2. That's all being divided by h. Now this looks a little bit unpleasant to me right now. I've got fractions inside of a fraction. So I'm just going to rewrite it right now. Instead of writing it where I'm dividing by h, dividing by h is the same as multiplying by 1 over h. So I'm going to write it as 1 over h times all of this. Okay, so next, let's see here. I'm going to simplify. Let's try to get a common denominator inside the parentheses. Okay, so I'll multiply the first fraction by 2 over 2. And I'll multiply the second fraction by 2 plus h over 2 plus h. That way they have a common denominator, so I can now combine them together. So in the numerator, we're going to have 2 minus 2 plus h. I want to be careful and put parentheses around it because I'm subtracting the whole thing. It's all over the common denominator. Okay, so here, when we distribute the minus sign, 2 minus 2 is going to cancel out. We're going to be left with a minus h in the numerator. At this point, we can cancel out the h on the bottom and top. That leaves us with the limit as h approaches 0 of, we've got a negative 1 remaining on top. And then we have 2 times 2 plus h. And if I try to evaluate at h equals 0, we're going to get a final answer of negative 1 over 4. Okay. So what that tells me is that the slope of the graph at this point is going to be negative 1/4. Finally, let's just take a look at one more rather quick example. Let's consider the sine function, sine of x. Okay, so its graph looks something like this. And so forth. And let's ask, what is the slope of the graph of the sine function at x equals 0, so right here at the origin. So notation-wise, that would be f prime of 0. Let's use the limit as x approaches a formulation. So I'm going to do the limit as x approaches 0, f of x minus f of 0 over x minus 0. All right, so f of x is sine of x. F of 0, that would be sine of 0, and sine of 0 is 0. And then x minus 0 is just x. So really, we're just left with the limit as x approaches 0 of the sine of x over x. And this is a special limit, which we covered earlier. We know that this limit is equal to 1. All right. So that tells us that the slope of the sine function at this point is equal to 1. Okay. All right, so that was fairly simple. I'm going to end my video at this point, and there will be one more video after this one. Thanks for watching.